students talking yesterday about how any boat with a hole in it will sink.
Huh. This sounds like a job for the MYTHBUSTERS! So, if we're talking about sinking and floating, then we must be talking about density.
Remember that density is the amount of matter packed inside a material.
Exactly. So if we look at this model of steel, you'll see that steel is far more dense than wood. There is far more particles packed inside this matter than there is this.
Remember, less dense
Floats,
more dense
sinks. So what we have here are density cubes. Each cube is the same size, yet made of a different material and different density.
Let's see what happens when we try putting copper in the water.
Huh, it must be more dense than water. Let's try pine. Pine is a type of wood. Interesting.
It floats, so it must be less dense than water. All right, let's get back to our sinking boat theory.
Today, we're going to use aluminum foil to represent an aluminum boat. We're simply going to mold it into a boat that will be able to sit on the surface of water using buoyancy. Later on, we're going to cut a hole in the center of this boat to see what happens. So what we have here is our great big ocean, or at least what will represent it today.
As you can see, when we place the aluminum boat in the ocean, it floats due to buoyancy.
Now, let's cut a hole in it and see what happens. So now that we've had the opportunity to cut a hole in the center of our boat, let's see what happens when we place it in water. Go ahead, Miss Neely. Interesting.
Sinks right to the bottom.
That must be because aluminum is more dense than water. So we're going to represent our next boat using styrofoam material, which we know is less dense than water. Let's give it a try in our ocean.
Less dense than water.
So just like last time, I'm going to cut a hole in the center of our plate, or our styrofoam boat, about the same size as our aluminum boat.
What do you think is going to happen when we put this boat in our ocean?
I don't know, but if it's anything like the aluminum boat, it's going to sink.
Let's see what happens when we place the styrofoam boat into our ocean. Even with the hole, it continues to float. And when I push it down, it returns to the surface.
Huh, that is so cool. Interesting. After all of that investigation, we've discovered that it really has to do with the type of material from which the boat is made. The styrofoam boat continued to float while our aluminum boat sank immediately. Sounds to me like this myth is busted. So after investigating both boats, what's interesting about our aluminum boat is that it's definitely more dense than water. Even before we cut the hole, when we pushed it down into the water, it sank. And even when we cut the hole, we didn't adjust the density. It still sank. It just sank a lot faster.
When we cut the hole in the styrofoam plate, it continued to be less dense than water, so it stayed afloat.
Right, because when you change the shape, the size, or even the weight of a material, you don't change the density, do you, Miss Neely?
Nope, you sure don't.
That's a common myth.